Hello, ready to start exercise number 2, batteries in series. So I've got my 3 batteries, I've got my battery holders, and I've got a voltmeter. So I'm just going to turn this on to volts DC. I've already got my patch cords plugged in. Now what I'm going to do is bring in one of the blue holders. This is very convenient. I can just pop the battery in just like that. Positive and negative. So I'm going to put the positive end. There's these very convenient hooks. Once the battery is in the battery holder, you can just grab the ends with the alligator clip. It makes it easy to read off stuff. All right, so this is one battery. Let's go see what the voltage is for one battery. Okay, why is it? Let me just check all of my connections here. It's a little, let's go see if it's, there we go. All right. Sometimes what happens is that the connections can be a little wiggly or loose. Now it's nice and stable. So there's my voltage for one battery, 1.561 volts. Now, how am I going to put another battery in series with this one? If you remember series from the resistor lab, we put them in piggyback. So I have another battery holder, and I'm going to put this one in here. But I have to remember to line up the positives in the same direction. So here, snap them in. See how it snaps in like that? I've got the positive in one hand going to the negative and then positive. So the positives are heading towards the left. So now I'm just going to hook up my voltmeter across both of the batteries. And we see 0. I must have hooked it up wrong. Oop. Negative, positive. There we go. Again, that was a matter of a loose connection. I don't know what happened, but the batteries were in the right way. I guess I just didn't push something in right. So now we have 3.1 volts, 3.1 volts. Now notice how that's 1.5 times 2 approximately. And also notice how for one battery, it was a little bit more than 1.5 volts. Let me show you. Let's have it listed on here. It says D battery on it, but I don't know if it says 1.5 volts anywhere on here. It's 1.5 volts. I don't know if it says it on here, but each of these batteries is 1.5 volts. And when they manufacture them, usually it's a little bit above that. Now, these are kind of old batteries, so they probably have a higher internal resistance. We're going to try and light up a light bulb with them later on, but let's go continue on and put our third bucket here and continue on putting them in series. So we want the positive end to keep going on in the right direction. So assuming everything is hooked in correctly, there we go. All right, so I have the negative end at the negative one battery and the positive end of the voltmeter on the other one. Now let's go see. The total voltage is 4.684. Now again, ideally, if there was exactly 1.5 volts per battery, that would be how many volts? 1.5 plus 1.5 plus 1.5. So the reason why it's a little bit more than that, more than 4.5, is because each battery is slightly more. In reality, when they manufacture these things, they have a little bit higher voltage than that. Okay, so we got 3 batteries in series. Compare your experimental results with the expected result. So what is the expected result? 1.5 plus 1.5 plus 1.5. That's the expected result. The experimental result is 4.684. So compare your results. This is using percent error. So you take the difference in the values divided by the expected result, which is 1.5 plus 1.5 plus 1.5. So then connect a miniature light bulb to each battery array in place of the voltmeter and record your observations. So if you look at the the data table number 2. So we filled out the original table. Now the brightness of light for one battery. So what I'm going to do is I'm going to take these patch cords. They're already across the array. I'm going to do one battery first, and I'm going to see if I can light up one of these bulbs. I'll just pick a bulb here. Let's see. I gotta make sure you guys can see it. There it is. It's kind of hard to see it. Oops. And let me just put alligator clips on these so I can clip on to one end of the light bulb like that. These are tiny little incandescent light bulbs. So they have a little filament in there, and it produces light by heating up. They're incredibly inefficient. 90% of the energy that comes in goes off in the form of heat. This patch cord is... Oh, look what happened. I can see something's happening. Let me unhook it. Okay, do you see the light? There's nothing there. Now watch if one light bulb... All right, did you guys see it? Very, 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 very dim, but you still can see it. Do you see that? Let me unhook that. All right, so the light bulb lights up, but it's extraordinarily dim. So this is with one battery in series. Now, what'll happen if we put two batteries in series? Well, let's just go and grab another one of my little guys here, and oops, gotta make sure I hook it up the right way. And now I'm going to place the leads across the entire bucket, and then wiggle around a little bit because I have to wiggle it around. Oh, there it goes. For whatever reason, these things, you need to like slightly maneuver them so that you get good electrical connection. And you can see there's a slight bit of rust down here. So sometimes what you have to do is, the best thing to do is sandpaper everything and just wiggle it. All right, so that definitely is brighter than the first one. So again, let's unhook it, boop, and hook it up. So it's very dim with one battery, quite a bit brighter for two. Now, let's unhook this and hook in the last one. So now we have 3 in series, and let's see how bright our bulb is now. Oh, our bulb isn't bright. All right, now here's my, there we go. Still looks like it's got a little power problem. All right, it's working. Come on, come on, come on. Well, it should be brighter. I think one of my D batteries, my D batteries is kind of poopy on it, but this should be the brightest. It actually doesn't, it looks about as bright as number 2 of the battery. So I think one of these batteries is a slight, has a little bit more internal resistance than the other ones. It does look a little brighter than the first 2 of them. That's kind of the idea. So what you're doing when you're adding batteries in series is you're adding energy. Each of the batteries will add some more energy to the circuit, which it'll be able to push more current through the wires, and the voltages add up. So when batteries are in series, the voltages add up to each other. Current's the same, but the voltages add up. And there's more, you can actually have more current flowing because there's more energy produced. But for each particular thing, there's one big loop of stuff going through. And I think that's it for this exercise, number 2.